Okay, so what we're going to talk about here is how to just graph and get the important information if it's a circle or an ellipse. Notice I've got two parent functions written out underneath the appropriate word, and what we have to do is when we see an equation, we're going to have to decide should it be this form or should it be the other form. And based on my classifying conics video, hopefully you can look at an equation in standard form and identify which one it's going to be. So let's just start with something like this. Okay, so if I saw this equation, the first thing I would do is try to figure out, is it a circle or an ellipse? Then I need to make it look like one of these parents. So when I look at this, this is going to be a circle because we have an x squared, we have a y squared, and they both have the same dilation on them. They both have an invisible 1 in the front. Now to turn it into the circle parent function, which looks something like that, we are going to have to complete the square. So here's my version of completing the square. I group the x's, leave a space. I group the y's, leave a space, and then any other extra number I move to the other side. So this plus 5 right now is going to be a minus 5 on the other side. And you know what? I can already tell this isn't going to work. See? This is how you learn. Okay, so let me make that a 1. So when we move it over, it's now a negative 1. Okay. So what we're going to do is fill in the missing blanks. And the way that you complete the square is you take half of the middle term, which is right here, half of that, and then square it. So negative 1 squared is 1, and then whatever you do to one side, you do to the other. Okay? Then over here, half of the middle squared, so half of this is a 2, and then 2 squared is 4. So if I fill in a 4 here, I have to fill in a 4 on the other side as well. And then we break it down, okay? So whenever we break this down or we factor these down, they factor into perfect squares. So it's going to look just like the form above. So the way that it breaks down, if you're not good at factoring, it should always be half of the middle right here. And that's sort of half the middle. That's the quick way to factor something if you're completing the square and you've actually done it correctly. Okay? And then over here we just add all this together and it's 4. Okay, cool. So now that we have this, we know that this is a circle, and based on the parent function, the center is at the point 1, negative 2. Notice you change the signs here, and that the radius, it's not 4, it's the square root of 4, or 2. Okay, and if that number had not had a perfect square root, just leave it as a radical. That would be fine. But that's how it would be, and then you could graph it. You could just go to the center and then go 2 up, 2 down, 2 left, 2 right, and draw a circle. Done. Okay, so now what about an ellipse? I'm going to erase so that I don't have to recopy that thing above. So with an ellipse, it would have been a very similar problem to what I just did. But the difference probably would have been in like the first step, where when we were looking across right here, maybe there'd been a dilation that was different than the other one. So this one's got an invisible 1 in front, this one's got a 2, different dilations, it's going to be an ellipse. So what we have to do is try to make it look like this one now instead. And you start the same. So the good news is you still start with completing the square. None of that's going to change. You just have to be really careful when completing the square here, okay? And the reason why is that you don't want to complete the square if you have a coefficient. So like on this side, we're still fine to take half the middle and square it. Whatever I do to one side, I do to the other. But over here, be really careful because that 2 is bad. So what I'm going to do is before I complete the square, I'm going to factor out that 2. And this is what I need to be doing completing the square on. So it may help you to even cross that out so we don't look back up there. All right, so how do I do that? Now I take half the middle, which is not a 4 anymore, it's a 2. Half the middle is 1, squared is 1. Now on this side, it's really tempting to say, oh, I did a plus 1, so let me do a plus 1 over here. It's actually not just a plus 1, it's plus 1, but then times whatever number was in the front. So this number affects it because it's touching that parenthesis. So make sure that you do that, and that's like where people mess up, is this step right here. All right, now we go on to the next step of completing the square, which is factoring. So x minus 1 squared plus, I'm going to recopy this 2, people, don't let it go away, y plus 1 squared equals, what does all this equal? 0, 2. It all equals 2. Okay. Now the rule here is that this looks and it feels like a circle equation, but we don't want it to. We want it to be a 1 over here if we know it's going to be an ellipse. And the best way to turn a 2 into a 1 is just to divide it by itself. But if you divide this by 2, you better divide everybody by 2, and then you reduce, and then you're finished. Reduce. I'm going to go ahead and write over 1 because that's going to help me graph later. And so now that you have this, we can see that the center is the HK, so, oops, positive 1. And the opposite of that's negative 1, so there's my center. 1, negative 1, good deal. And with an ellipse, the way that you graph it, it's really pretty easy. Whatever the bigger number is going to be your major axis. So on this one, the major axis is horizontal because the bigger number is underneath x. So I know it's going to be bigger side to side than it is up and down. And the way that you actually find like your vertices is you just take the square root of that number, okay? And I'm going to go left and right a distance of the square root of 2. Now you may not know the square root of 2 exactly, most people don't, but you know that it's like 1 point something, okay? So I'm going to go, let me change colors here, I'm going to go left 1 point something, like a little bit more than 1. I'm going to go right, I got my left and right confused, there we go. I'm going to go left and right the same distance. That's my distance of root 2, okay? Now as far as my co-vertices, I'll do this in blue. So the blue ones are the vertices. The co-vertices are on the minor axes. So this is how far up and down you go, and you get that number by looking under y for your up and down and taking the square root of that. So I'm going to go up and down the square root of 1, which is of course 1. So up and down 1. So what happens is you end up making sort of a flatter ellipse, like a football or something. There we go. So that's what it's going to look like. Now to get your foci, the way that you get your foci is, I'm sure you have formulas for it in class, but the way I do it just for my equation is I take my 2 denominators and I subtract them, and that's all under the square root. So 2 minus 1 is 1, and then I square root that and I get 1. So my foci are a distance of 1 away from the center, and but they have to be on the major axis, okay? So that's why it was important to sort of talk yourself through the major axis earlier. So I know the major axis is horizontal, so I'm going to go left and right 1, and that is going to be where my foci are. So hopefully that helps get you started. I'm here if you get stuck, but that's the main idea on graphing an ellipse, graphing a circle, and completing the square at the same time.